So in this problem, you've got this four-step process there. The one AB, the line segment AB, this part that's vertical right there. How much work do we do there? Zero. We're basically just heating it up, but the piston doesn't move, so heat flows in, but it doesn't do any work, right? So this is, work is zero, and that's because delta V is zero, right? For process BC across the top there, well, that definitely is some work, right? Our pressure is 500 pascals, so it's 500 pascals. And then our delta V is it positive 0.5? Yeah. Right? And then this is cubic meters, so this is going to be, is that 250 positive? Yeah? Okay. And then CD, the piston doesn't move, so no more work, right? So CD is work equals zero, right? Okay. And then DA, the district attorney, there is work, yes? Okay. And so it's, what's our pressure now? 200, so the work is 200 pascals times negative 0.5 cubic meters, right, because it's compressing. And this ends up being negative 100 joules. Now, what is the net amount of work done? 150. So because we expanded at a higher pressure than we compressed, we get work out of this. Yes, does that make sense? Now, the second thing you got to realize, yes, sir. That was going to be my concept number 2. So yeah, hang on to that idea, exactly right. Okay. Concept 0 though is that this is what your car does. Yeah, go for it. Right? Your car is actually doing both things. It compresses gas, it expands, right? When it's expanding, it's doing that at a high temperature. It has just ignited gasoline inside the engine, yes? And it's fiery hot. So the power stroke is at a very high pressure. The compression is at a lower pressure, yes? It compresses stuff starting at atmospheric pressure and goes up from there. Okay. Now, there's two ways to get more power out of this engine. And what Evan said was exactly right, was that it's the area inside here that is the work. Okay. So there's two ways to get more work out of it. One is to make it explode at a higher pressure. And of course, a powerful engine, you're going to push that as far as you can, but you can't push it too far because the engine will just blow apart, right? The other thing you can do, though, is can't you bring this down? If you bring this line down, don't you get more work per cycle? Yes? So how do you do that? You lower the temperature at the low end. So this is a crazy thing. There's a sports car. I know Mazda RX-7s have this. There's something called an intercooler. Okay, a cooler, it cools the air going into the engine. It's like an air conditioner for the air intake of your engine. Now, on the face of it, this sounds like a bad idea. Because isn't the engine like something where fire and heat drive the car forward, yes? Yes. No, the Mazda RX-7 cools the air down so that as it's compressing the mixture, it has less work to do. Therefore, it gets more power out of every explosion that it gets. Isn't that wild? I don't know. It's crazy. Yeah. Okay, the other way to do it is, of course, what they just said, right, is look at the area inside this, right? This thing is 300 pascals this way, right? It's 0.5 cubic meters this way. Just pretend you're laying carpet. This is 300 times this area right here, right? The area equals 300 pascals by 0.5 cubic meters. That's a 5. I don't know what it became. Come back there. Yeah? And that as well is 150. You have to be careful, though, because you have to make sure that the power stroke is going to the right on the top there, the main thing. If it's going the other way, then it's something else. Right? And they have those. You've got both of those around. This is your car. It's moving out when it's fiery hot, moving in when it's colder. Right? Your refrigerator is the opposite. Your refrigerator goes the other way. Okay, your refrigerator is compressing at a high pressure. That's the hot side. The coils where your cat lies down. That's the hot side of the fridge, right? And then it's expanding at a low temperature, and that's inside the freezer box. So if you run it the other way, you're using work to make heat flow from cold to hot, And if you run it this way, you're getting work from letting heat flow from hot to cold. Yeah? It's kind of a crazy thing. Yeah. One's a heat engine, one's a heat pump. Okay, so area, you can do either one to solve these. You can solve for the area inside. You could just add up all the cycles. If you forget the whole area thing, right? Just be careful. If it's anti-clockwise, it's negative work. If it's clockwise, like this guy, this is positive work. Clockwise is positive, anti-clockwise is negative. And you might forget that. Boys and girls. So here's the easiest way to remember it. Look at the top cycle. If it's moving to the right and the top thing is positive, then the net process is positive, correct? Yeah? So just look at the top thing. If the top is to the right, then it's a positive work done. That's right.